This video shows the requirements, the calculation, post-hoc testing, effect size calculation and interpretation, as well as reporting the results for the Kruskal-Wallis-test in R. Its purpose is testing 3 or more groups for differences, or put more technical, if they originate from the same distribution or not. In my fictitious example, I have 3 study groups. The first one received no intervention, therefore serves as the control group. The second group used meditation, and the members of the third group had mentors. I used the Kruskal-Wallis-test to test for a difference in the grade point average, GPA, between those 3 groups. Let's quickly talk requirements. You only need 3 or more independent groups, and the dependent variable should be at least on the ordinal scale. As a first step, after importing data, I want to see the mean, standard deviation and median of the GPA for my 3 groups to get a first look. I recommend the psych package for that and its described by function. Please note that it is advised to have the group variable as a factor in your data frame. I can see that the median of the control group is the lowest with 1.7. The group of meditation had 2.85 and the group of mentors 3.3. You can also visualize the 3 groups by using box plots and seeing the interquartile range represented by the height of the box and the median by the black horizontal lines. Now I want to test whether the medians are significantly different from each other. For this, I use the kruskal.test function and start off with the test variable, the GPA score. After that, I use the tilde, that small wave symbol, and put the group variable behind it. I can now run this line and get the results. If the p-value is below the predefined threshold, for example 0.05, the null hypothesis can be rejected. Reminder, the null hypothesis assumes no difference of the medians between the tested groups. In my case, I defined alpha as 0.05 and can therefore reject the null hypothesis, because my p-value is very small, 1.12 times 10 to the negative 7. I can therefore conclude that the medians are different. After a significant Kruskal-Wallis test, post-hoc tests should be calculated. An effect size for the Kruskal-Wallis test itself is optional. In case a Kruskal-Wallis test turns out to be significant, it is of interest to the researcher between which of the groups differences can be observed. To achieve this, pairwise comparisons are being used. This can either be done using Wilcoxon-tests or Dunn's tests. The latter is preferred though, because it performs better when you have tied ranks, which is more likely the larger your sample is. In order to calculate Dunn's test, we load up the rstatics package with the installed packages and library functions. Now I have access to the Dunn_test function. Simply put the dependent variable first, add the tilde, the small wave symbol, and finally the group variable. Add the argument data equals to specify in which data frame your variables are. Finally, the p-adjust method argument is required to counter the alpha error inflation caused by multiple pairwise comparisons. The easiest and also most conservative one is Bonferroni, where your p-value will be multiplied with the number of pairwise comparisons being done. Other methods like Holm, FDR and so forth can be found in the documentation of the Dunn_test function and used accordingly. Albeit, your choice needs to be justified, at least with research field specific standards. Eventually, we get a table that shows all pairwise comparisons. In the last 2 columns, their respective adjusted p-values are shown, as well as significance indicators on the 5% alpha level. In my example, I can observe differences between the control group and meditation group, as well as between the control group and mentoring group. The mentoring and meditation group have a p-value some might still consider for further investigation and/or interpretation. Please consult the paper, the ASA statement on p-values, and draw your own conclusions. Finally, you might have a significant Kruskal-Wallis test and no low enough p-values in post-hoc testing when controlling for alpha error inflation. Just keep in mind that a p-value, to which it all boils down to, is simply a function of sample size, which decreases with an increase in sample size for any effect size that is different from 0. So a non-significant test result in almost all cases tells you you're lacking statistical power as a result of too small of a sample. Don't, and I repeat, please don't use post-hoc power analysis to justify your non-findings, because the observed power is a one-to-one function of the p-value. After doing a post-hoc test, you should calculate the effect sizes for observed differences. It is common practice to calculate the effect size R after observing differences with Dunn's test. R equals the standardized test statistic divided by the square root of the number of observations of the 2 groups that showed a difference. We can easily do that by putting the results of the Dunn's test into a vector, which I call D. I can now calculate R within D. I specify D $R as the test statistic divided by the square root of the sum of the 2 groups each time a pairwise comparison is conducted. Now I can request the results and see the effect sizes for each comparison in the last column, called R. Finally, you have to classify the magnitude of the effects. If similar studies in your research field exist, compare your effect size with the given ones. If no comparable study exists, however, use the common thresholds within your research field. If those are also non-existent, you can refer to Cohen 92, a power primer. Page 157 shows 3 thresholds for the effect size R. If it exceeds 0.1, it is a small effect. If it exceeds 0.3, it is a medium effect. And if it exceeds 0.5, it can be classified as a large effect, as is the case in my example. When you're done, you have to write up the results. First, one formulates whether the groups are different or not, providing the test statistic alongside the degrees of freedom as well as the p-value. You might also want to add the eta squared or f effect size for the overall test, just for comparison's sake. In case of calculated post-hoc tests, the observed group differences with small enough p-values are reported using the p-value. When you were able to observe an effect based on a pairwise comparison, report the calculated effect size R. Finally, the magnitude of this effect is classified with, for example, Cohen 92 or the research field specific thresholds.